We've talked a lot about sine and cosine properties, but what about the composite argument property for tangent? So for tangent, we're going to go back to our quotient property, and we're going to use the quotient property very heavily throughout all of these proofs. So we say tangent of a minus b is sine of a minus b divided by cosine of a minus b, and then write out the property for sine of a minus b and for cosine of a minus b. By the way, I don't expect you to write all of this down. I just want you to see where things come from, and you can feel free to kind of go through this fast if you want to. But if you're interested, this is where it comes from. Now, I want to turn these into tangents. So to turn these into tangents, I'm going to add a division. Basically, I'm going to divide the numerator and the denominator by the same thing, which is cosine A, cosine B. Why cosine A, cosine B? Because some mathematician a while ago decided that was a clever thing to do, and it ended up nicely. And that's basically what you do when you're playing around. You play around with stuff until it turns out nicely, and this is what turns out nicely. So that means I'm going to divide both terms in the numerator and both terms in the denominator by cosine A, cosine B. So that gives me four kind of complicated fractions here. Now what we notice here is the cosine B's divide out here, the cosine A's divide out here, so we end up with sine A over cosine A, which is tangent A, sine B over cosine B, which is tangent B. Cosine A, cosine B over cosine A, cosine B is 1, and then we have sine A over cosine A and sine B over cosine B, which is tangent A, tangent B. So here is what the property looks like, and here is what you should write down on your, at the bottom, somewhere on your double argument properties that has, or sorry, on your composite argument properties at the bottom, or somewhere in there, write these two properties down. So this is the composite argument for tangent of A minus B and tangent of A plus B. Those aren't used a whole lot, but the tangent, except for tangent of A plus B, leads us to a property that is really important in calculus. First of all, the double argument property for tangent is we're going to find the same way as we would for cosine and sine. We would replace A and B both with x. So if you have tangent x and tangent x, that becomes 2 tangent x. And then tangent x times tangent x would become tangent x squared. So this would be the double argument property for tangent of 2x. Now that's going to lead us then to a really important property that's used in calculus. So recall you have your original cosine of 2x property, and then by doing substitutions with the Pythagorean property, we get two other versions of cosine of 2x, which we then solve for the squared term here. So when I solve this property for sine squared of x, I end up with sine squared of x is 1 minus cosine of 2x over 2, or we could say 1/2 times the quantity 1 minus cosine of 2x. Either one is fine. When I solve the one in green here with the cosine squared in it for cosine squared, then I end up with this property. So now I have a sine squared and a cosine squared x, so now I can figure out a property for tangent squared. So tangent squared would be sine squared divided by cosine squared. So I'm going to put in the property for sine squared divided by the property for cosine squared and multiply both of those by 2, so it eliminates the 2 in the denominator here. And so here is our property for tangent squared. Tangent squared of x is 1 minus cosine of 2x and 1 plus cosine of 2x. These three properties, sine squared, the cosine squared, and the tangent squared, that all end up with something with cosine of 2x in them, are called the properties for reducing powers. And these are all three really important for calculus, because there are times when a calculus procedure cannot be done if the function is squared, but it can be done if the function is not squared. So this gives the opportunity to rewrite a squared trig function in terms of an unsquared trig function, which is going to be really useful. So those are three. If you're taking calculus next year, definitely write this one down and make a note of these as reducing powers properties. Are very, or properties that allow you to reduce powers. They are very important.